I'm going to bet that you know more about some thermodynamic properties than you might give yourself credit for. And then you're going to need to pick up some new concepts that I'm going to introduce you to in this next video. So this is just an introduction to properties, many of which I think you're already familiar with. It's my bet that on this slide, so here's you, and in the your living experience so far, I'm going to bet you there's a good number of properties that you already have a good working understanding of. Pressure. If you've ridden a bike or you maintain the pressure, air pressure in your car tires, you have a pretty good physical feel for what pressure's all about. Um, I'm quite sure that you have a good feel for what temperature is all about. You know when you're cold, you know when you're hot, and why. And you have a pretty good feel for the measure, at least in terms of living, what you're comfortable at, what you're uncomfortable at. You've been through high school, you've been through some introductory courses so far in college to where you're expected almost just as a matter of daily operation to be able to calculate the volume of certain basic shapes, the volume of a cylinder. Gosh, you know how to do that already. Um, Density. I'm going to bet that in maybe physics, maybe in college chemistry, you've already been introduced to the idea of the density of certain substances. You have a physical feel for certain substances that are more dense than others. You know that a brick is much more dense than air. You've got that figured out already. And also, you have some experience with batteries. Gosh, a car battery and batteries that store energy to provide you with electric power for all kind of applications nowadays. So there's plenty of things that you know about already. One thing I need to cover with you that's covered in your textbook and is going to be important to have a general understanding of as we go along in this class is the idea of categories of properties. And the two categories are an extensive property and an intensive property. So the properties that we're going to cover fall in one or the other of those categories. An extensive property depends on the entire system. So I've tried to start with my tried and true sketch of a piston and cylinder with my control surface shown, showing that the gas contained inside the piston and cylinder is the closed system, not the piston itself. It's the air contained in the system is the closed system. So an extensive property would depend on the material contained in the entire system. An intensive property doesn't depend on the entire system, but it's representative of all the material inside that closed system. Let me try to think of a way to visualize this to maybe try to explain this a little better. I know, volume. Volume is an extensive property. And so do you see that if I were to maybe try to study half of this system, let's say the right-hand half of the system over here, common sense tells you that if I'm looking at the right half or the left half, the volume of those halves is going to be half of the whole system, right? So could I convince you that volume is an extensive property? Depends on the whole system itself. How about density? If you wanted to study the right half of what's in the system compared to the left half, density, the density of the air here is really going to be the same as the density of air over there, isn't it? And so, for example, the density of the air in that system would be an intensive property because it's independent of the size or mass of the system itself. And look at the units, kilograms per cubic meter. And that's a good way to detect whether a property is intensive or extensive. Now let's go through some figuring out certain properties that you're already familiar with let's go through that exercise of identifying them as extensive or intensive. Okay, so here's our list. Here's my little sketch. So let's see how this would apply to this closed system. How about pressure? How about the pressure in the system? Intensive or extensive? What do you think? The, how would the right-hand side compare to the left-hand side? Temperature in degrees F, degrees C, degrees K, those would be the units of temperature. If you could sort of explore within this, if you could float around yourself inside this piston and cylinder, how would the temperature within that system compare, let's say over in this corner versus this corner? How about the volume in cubic feet or cubic meters? Well, we just covered that one. How about the density, kilograms per cubic meter? We just covered that. How about the mass contained within the system? Would that be an intensive or an extensive property? Similarly, the weight of what's in that system in newtons, would that be intensive or extensive? Just think in your mind. Pressure, intensive or extensive? Temperature, intensive or extensive? Et cetera, et cetera. Let's go with the answers. Okay. Pressure, that is an intensive property, isn't it? Common sense tells you that if I'm looking at this corner of the system, the pressure is so many pounds per square inch or so many kPa. If I were to travel over in this area, the pressure, it's all the same within the system. And doesn't that make sense that the temperature, the same kind of mental exercise for temperature, same. The volume, the total volume within the system, that's an extensive property because it depends on the size of the system. Density, kilograms per cubic meter. That's an intensive property because the density here is the same as the density there. The mass, of course, that depends on the size. If you cut your system in half, you're going to have half the mass. Same thing as if you cut your system in half, you're going to have half the weight. So that's the exercise, and really, that's what you think. Gosh, this was so simple. There's no number crunching. I got this figured out. I think that's great, but please put in the back of your mind, there's two categories of properties in this class, an intensive property and an extensive property. And so all of a sudden, we're here to recap. Intensive property doesn't depend on the size of the system. Constant through it, the same throughout the whole system. That sampling idea where you cut the system in half. An extensive property does depend on the size of the system. If you cut the system in two parts, how would that property compare from the original way you define the system? Well, that brings us up. That's got it. I see the next video is going to be pressure. And so for the next, I think, 3 videos, what I do is try to take a detailed look at the properties you've already got some familiarity with, but I do want to give you some engineering details that I hope are going to help you feel more comfortable in the class and be able to deal quantitatively with the properties that you already have a pretty good familiarity with. So I hope that helps, and encourage you to keep plugging along and look at the next video.